Yeah, good evening students. Today we are going to learn about the D-type flip-flop. So it is also called as delay flip-flop. And here we represent how this circuit is represented in your circuit theory. This is your one input and this is your clock, and outputs are your present state, and here we are using preset and clear button. So here it is D, clock, preset and clear. This is Q and this is complement port Q bar. This is how we represent this flip-flop, and it is simply just you can choose JK flip-flop or SR flip-flop. And how this flip-flop will be converted into D, both inputs are connected with the same input. So here we draw a SR flip-flop. There are two inputs, or you can say J or K, and there is a clock and preset and clear button also, and the outputs are Q and Q bar. So here it is Q, Q bar, clear and preset, and this is your J and K, and here it is clock. So how this will be converted into D? There are two inputs J and K. Both inputs are connected with the same input, that is called as D. Named as D, and D is also called as data input. And here this second input is connected with NOT gate. So this is how you convert JK flip-flop into D-type flip-flop. So if we consider SR flip-flop, so here we show the diagram. There are 4 NAND gates you are using. You already know about the SR flip-flop. It is simply a latch circuit. So there are 4 NAND gates we are using. One input is S, suppose, and second input is your R. And there is clock, which is connected with both gates, and their output of this gate will be connected as the input for another gate. This is Q and this is Q bar. This is also connected as input to the circuit, and this is Q connected at input to this circuit. And there we are taking two inputs, so how we connect? We use here a NOT gate and one input here. So this is D, it is your Q, you can say Qn or Qn plus 1. It is complement port, that is Qn bar, and the next state is Qn plus 1 bar. It is Qn and Qn bar. Okay, this is the circuit and this is the clock here. Now how the circuit work and how this is used as a delay circuit. Here we make a table side by side and know about the working of the circuit. So here we are taking the input first. Input is your D, present state and your next state. So we are mostly consider the next state. First input is D, second is your Q1, that is your present state, and this is your Q1 plus 1. So if there is one input, so the possible inputs are, it can be 0 or it can be 1, and we always taken the present state as don't care, it is always be as input. So we mostly consider about the Qn plus 1. So first, when your D input is 0, then how this circuit works. So Qn plus 1 will be, what is this? So Q1, suppose we are giving the name of the gates, G1, this is G2, and this is G3, and this is G4 gate. So we get the Qn plus 1 from the G3 output. So when we apply the 0 input to this circuit, means this is now 0. Okay, and here this will be converted into 1. So G2 input gate is 1 now, and clock is always be 1. Then the G1 will be output as 1 and it will be 0 simply. Then how this will be calculated? So Qn plus 1, it is the output of the G3. So one input of G3 is 1 dot, second input is your Qn bar, and it is passed through the NAND gate, it will be bar. So output is Q1. So here we did not get any input, means output 0 or 1. So we go for the complement port. So Q1 plus 1 bar, what will be the Q1 plus 1 bar. So this is the output of G4 gate. So one input in G4 is 0 and the second input is Qn, and it is passed to the NAND gate, which is Q1 bar. So 0 multiplied by anything is 0 bar, and 0 bar is 1. When this port is 1, then Qn plus 1 is 0. So here we write Qn plus 1 is 0. Now second condition, when d is equals to 1, what will happen? Qn plus 1, which is equals to Qn plus 1. What will be the Qn plus 1 when d is equals to 1? When d is equals to 1, it is passed to this circuit, and this will be treated as 0 because NOT gate will convert this input as 0. So it is comes out 0 after passing through the G1 gate, and this will be 1. So what will be the G3 output? It is taken as 0 dot Qn bar and bar, which is equals to 0 bar and which is equals to 1. So here we find the value, means 1 is, when d is equals to 1, then Qn plus 1 will be 1. Here we can see that what you applied as input, जो भी आप apply करेंगे input 0 और 1, you will get the next state as 0 and 1, means same input and same output but some delay, because it is passed through the circuit. There is a difference in the timing, means you get the next state in the nanoseconds, so there is some delay. So that's why this circuit is called as delay circuit. So we can write it here as the output Qn plus 1 at the end of clock pulse equals to Qn before the clock pulse, means input data appears at the end of the clock pulse. So transfer of data from input to output is delayed That's why this circuit is called as delay or D flip-flop. So this is all about the D-type flip-flop.